Hi, good evening, everyone. In today's class, we are going to go ahead and we are going to take some questions from again the vector space. They're going to be more on the topic of basis, dimension part of vector space. And I think I would be able to wrap up all questions related to vectors maximum by the end of this week. So next week we will dedicate to doing questions from macroeconomics. Okay. Next week's marathons will be on macroeconomics. So, if you want to go ahead, you can take the weekend, Saturday, Sunday, and revise macroeconomics so that you understand the MCQs better when we take them in the live classes. Okay. Look at the first question, try to do it yourself, try to answer this one, then I will answer this question. Give it a try. Write your answers in the chat window. Anyone? So what is dimension of a matrix? How do we find the dimension of a matrix? The dimension of a matrix is the number of unique elements in the matrix. So for example, it's more than that, but for example, what dimension means is that if I want to generate any matrix, say I want to generate a 2 cross 2 matrix, then how many standard matrix would be required to generate this 2 cross 2 matrix? So we have 4 standard matrices, right? The first one is 1, 0, 0, 0. The second one is 0, 1, 0, 0. The third standard matrix is 0, 0, 1, 0. And the last standard matrix is 0, 0, 0, 1. So, we always want to create a given matrix as a linear combination of these matrices. So I can say alpha 1 plus alpha 2 plus alpha 3 plus alpha 4. And if you will be solving this side, if you will be solving this, what will you get? You will get alpha 1, alpha 2, alpha 3, alpha 4 equal to A, B, C, D. It means that it will go ahead and it will give you alpha 1 as A, alpha 2 as B, alpha 3 as C, alpha 4 as D. So as these alphas will be taking different values, you will be able to generate different matrices. So for example, if I want to generate a matrix 1, 4, 5, 6, it means that the first matrix should be given a weightage of 1 because alpha 1 is equal to A. The second matrix should be given a weightage of 4. Third should be given a weightage of 5 and last should be given a weightage of 6. So this way we can go ahead and we can use these 4 standard matrices to generate this matrix, right? We need 4 different alphas for it, right? So dimension of any M cross M matrix. I have talked about dimension in my advanced video lecture. You can also have a look there. So dimension of any M cross M matrix is M into M. Dimension of any M cross N matrix is M into N. Right? Dimension is simply the number of elements, rows into column. Now, if I just go ahead and if I look into the question, ab kya hai yahan pe? It is saying that this is a symmetric matrix that I want to go ahead and I want to generate of order 5. So one property about the symmetric matrix is that we have the elements above the diagonal and below the diagonal to be the same. Mane, if I create a 2 cross 2 symmetric matrix and I have 4, 5, then this will be 5 and 10. So if this is A, I will also have A transpose equal to A. I will have A transpose equal to A. For that, what do I require? I require that these off diagonal elements should be equal. Right? So which means that we have done this property in matrices that if it is a 2 cross 2 matrix, the first row, it has 2 unique elements, but the second row will only have 1 unique element. So the total number of elements will be 3, right? We have already seen that if it is a 3 cross 3 matrix, suppose, so just yahan pe 1, 2, 3. So I know I need a 2 here. This can be 4. I know that when I want to transpose this, I need a 5 here. This can be 6. When I transpose, I need a 6 here, and this can be 7. So when I go ahead and I transpose a matrix, then I should be able to go ahead. Sorry, this is 3. And this is 6. When I transpose this matrix, I should be able to get the same matrix. So isme kya hoga? I have n elements, n unique elements here. Is case mein wo n ho gaya 3. All 3 unique elements here. I have 2 unique elements here. And I have 1 unique element here. So 3 plus 2 plus 1. That means 6 unique elements. So the dimension becomes 6. अब यहाँ देखो, it says order 5. It means that the first row will have 5 unique elements. Second can have 4 unique elements, 3 unique elements, 2 unique elements, 1 unique element. Right? So what will I get the answer as? I'll get the answer as 15. So the dimension should be 15. So the dimension of this subspace of order 5, it will be 15. But you can also do it for a general case. Just for example, if I would have asked you, what about order n? Then what will be the dimension of a symmetric matrix of order n? So we are adding the first n elements. When order is 5, so we are adding the first 5 natural numbers. So if order will be n, we will add the first n natural numbers. And what is the sum of first n natural numbers? It is n plus 1 by 2. n plus 1 by 2. So we know that the dimension of a symmetric matrix, it is going to be n plus 1 by 2. Now just put n as 5 and check. What will I get? 5 plus 1, 6 by 2, 30 by 2, which means 15. So answer is coming as 15. So the order of this matrix will become, the dimension of this matrix will become 15. Any doubt in this? Anyone who's not clear with what we are doing? Okay, let us go to the next question now. Try this one. This was asked in DSC 2011 paper also. Okay, give this a try. Try to do this question. Suppose V1, V2 till Vn is a set of linearly dependent vector, none of them being 0. C1, C2, Cn are scalars, not all equal to 0. But you are given that summation Ci, Vi is 0. What is the minimum number of non-zero scalars? Give it a try. Try to do this question. This is one of the most common topics in exam, and you have to go ahead and understand this topic very well from exam point of view. Definitely it will be asked in exam, in IIT exam. Okay, A. What about others? If you don't know how to solve, try by doing elimination of the options. That can also help. Zaruri nahi hai that you would know how to solve each question, right? But elimination of options will always help you to solve these questions. Let's give this a try. एक एक चीज देख लेते हैं. So what it is saying v1 v2 is set of linearly dependent vector. So let's just revise the concept of linear independence and linear dependence. When are vectors said to be linearly independent? When C1 V1 plus C2 V2 and so on till Cn Vn, it is equal to, so this is equal to 0, implies if and only if all Ci's are 0. That means you are having a trivial solution. The only C's that solve this equation is when C's are 0. Then it is called as linearly independent. This is definition number 1. Better definition number 2 is what? In terms of determinant, vectors Vi, V1 till Vn, they are linearly independent if determinant of vector is non-zero. Then they are linearly independent. Definition number 3. They are linearly independent if rank of the matrix created from these vectors, it is equal to order of the matrix. Same ही बात है. Determinant non-zero. Then they are linearly independent. What do we get for linear dependence? क्या definition रहेगा linear dependence का? It is linearly dependent if C1 V1 plus C2 V2 and so on till Cn Vn equal to 0. It is true for Ci's non-zero. There exist at least some Ci's which are non-zero. For example, बहुत simple सा example है. Suppose I tell you that there are two vectors. And I tell you C1 is 1 and C2 is minus 1. So what will I get? 1 into V1 plus minus 1 into V2 is equal to 0. Mane I will get V1 minus V2 equal to 0. Mane I will get V1 equal to V2. So it means that there is some dependence na. V2 is dependent on the value of V1 because V2 is equal to V1. So V2 is dependent on the value of V1. So it means that there is some dependence that we have here, isn't it? So when these C's take non-zero values, it means that there is some kind of dependence which is there. But when these C's take zero value, if it is only possible to get 0 by doing this, 0 V1 plus 0 V2 is 0. That means I am getting what is called as a trivial solution. So it means that they are independent. There is no relationship between them. कोई relationship नहीं है. So therefore, what we can say is that when C1 V1 plus C2 V2 and so on till Cn Vn is 0, for these C's not equal to 0, when these C's are not 0, they are non-zero, then we can go ahead and say that yes, they are linearly dependent. The other definition can be if determinant is 0, then they are linearly dependent, or if rank of the matrix created is less than the order of the matrix. Again, meaning the same thing, that determinant is 0, then they are linearly dependent. So this is the definition for linear independence and linear dependence. 3 definitions. 3 main definitions. Okay. But now let's go ahead and look at what the question is saying. So question is saying that V1, V2 till Vn, it is a set of linearly dependent vector. Mane, we are saying that C1 V1 plus C2 V2 so on till Cn Vn ये तो 0 है. But for not all Ci's equal to 0. There are some Ci's which are non-zero because it is linearly dependent. Now it says none of them being 0. Mane no vector themselves is 0. All vectors are non-zero. Suppose C1 to Cn are scalars, not all 0, such that this holds true. I've already written this. Minimum number of non-zero scalar will be. Minimum number of non-zero scalar will be. So let's try with option number A, beta. Let's try with option number A. That means 1. So 1 says that, this means that, A means that only one scalar is non-zero and other scalars are 0. सिर्फ एक स्केलर नॉन जीरो है और बाकी सारे स्केलर जीरो हैं, तो व्हाट विल वी गो अहेड एंड गेट कि C1 V1 all other scalars are zero. That is what option A means. 0 into V2, 0 into V3 till so on, 0 into Vn is 0. So C1 V1 is 0. ठीक है, we have assumed that C1 is non-zero, एक scalar non-zero है and every other scalar is zero, बाकी सारे C's zero हैं. This is what option A is telling me. The minimum number of non-zero scalar is 1. So only one scalar is non-zero and others are zero. So now we have got this as C1 V1 equal to 0 when we go ahead and when we simplify this thing. अब एक बात बताओ, what is given to me in the question? That all vectors are non-zero. So if all vectors are non-zero, what will I get? I will get C1 as 0. But option A says that C1 is non-zero. One scalar is non-zero. So I have reached a contradiction. I've reached a contradiction. This is the sign for contradiction. I've reached a contradiction. So I can go ahead and I can say that option A cannot be correct because I've reached a contradiction. Now try with option B. B says that two scalars are non-zero. So let's start again. So what will I go ahead and get? I will get C1 V1 plus C2 V2 and so on till Cn Vn equal to 0. Now option B tells me that all scalars 0, two scalars non-zero. यही तो बोल रहा है option B, that I have two scalars which are non-zero. Okay, let's put C1 not equal to 0, C2 not equal to 0 and other scalar 0. So what will I get? C1 V1 plus C2 V2 plus 0 into V3 and so on till 0 into Vn equal to 0. So I will get C1 V1 plus C2 V2 equal to 0. Right? This is possible. There is nothing wrong with this. I am getting summation Ci Vi as 0. I am able to verify this condition and I am not from anywhere here getting that C1 and C2 are 0. I am able to satisfy the condition that both are non-zero. It is possible now, one is positive, one is negative, and then they cancel out and give me the answer as 0 and they satisfy the condition. So it means when two scalars are non-zero, I will be able to satisfy what the question is telling me to do. So yes, answer 2 is correct. This is the minimum number. सबसे कम number ही तो बताना था. So I will not exceed beyond 2 because 2 is able to go ahead and satisfy this condition for me. So the answer to this question is 2. So all of you who have said B, that is the correct answer. Yes, it is correct. Any doubt in this? Anyone? Are we clear with this? Okay, let's go on to the next question. Try the next question now. Give this one a try. I'm not sure if this is from DSC or not. Just give this a try.